Okay, let's get into lesson 19. I'm going to reverse lesson 19, do the similar triangle part first, since we just talked about similar triangles. Similar triangles, here's the definition, when two angles in one triangle have the same measure as two angles in another triangle, then the third angles are equal. Sorry, I spelled that wrong. The triangles would then be similar and the sides are proportional. So what this one's saying is if we know that this angle, the color that shows up, if this angle is equal to this angle, and this angle is equal to this angle, then we know that the third angles are going to be the same. Because if they both add up to 180 degrees, and you take this amount away from 180 degrees, then you're going to be left with the same amount for the third angle. So these are going to be equal. So when two angles in one triangle have the same measure as two angles in another triangle, then the third angles are equal. Okay, let's go down here. This is the same thing as we did in the last lesson with similar triangles. Except they only give you two angles that are congruent or equal. So they're saying that these two angles are congruent, and that would be because of vertical angles. When angles are opposite each other, if they're vertical like this, they're equal. And then they're giving us that these two angles are equal. They'll sometimes call it congruent. That means it has the same shape. So we know that if we have two angles congruent to two angles of another triangle, then the third angles are going to be congruent. And if three angles in a triangle are congruent, then the two triangles are similar. And if two triangles are similar, then their sides are proportional. So I did this really quick over here. I actually took this triangle right here, and I flipped it so that it looked the same as this triangle. I made it a little bit bigger by accident. But this triangle, if we just rotate it along this center point like this, it's going to look like this. And we can see easier that 5 goes with x, 7 goes with y, and 4 goes with 6. So if we're going to figure out the sides, we just set up a proportion. We would say x is to 5. Here I wrote x is to 5 as 6 is to 4. Now you can always go the other way around. You could have said 4 is to 6 as 5 is to x. It's the same thing. So you just cross multiply, set up your proportion, and you get 4x equals 30, 30 over 4, and then we always reduce it, and we get 15 over 2. And then you do the same thing for y. So you would say y is to 7 as 6 is to 4. You could reduce it right here, like this, and say 3 over 2. Then you cross multiply, and you get 2y equals 21, or y equals 21 over 2. So that should be really similar to the last lesson. I don't use a scale factor, but if you feel more comfortable using it, if you've used it before, feel free to do that. Okay, we're going to move to the word problem section of this lesson. Hopefully this is review. I think we did it last year, so we'll just go through it rather quickly. See over here. We'll make this recording angle size smaller. Do that. Okay, so example 2, Karamagu had 50 nickels and dimes, whose value was $4. How much of each kind of coin did he have? Okay, keep in mind that these are value word problems, and we're actually going to use subscripts. When you have value word problems, you're going to have two equations, because we have our nickels, and I'll call those number of nickels, like this. Number of nickels, and we have our dimes, number of dimes. So already we have two variables. You need as many equations as you have variables. So if you have 3 variables, you're going to need 3 equations. Here we have 2 variables, so we're going to need 2 equations. When you do coin problems, you're always going to have 2 equations. One's going to be the value of the coins, and the other equation is going to be the number of coins. So this one, let's set up our value equation. So we're going to have our value equation and our number of coins equation. So our value, we have 50 nickels and dimes, whose value is $4. Well, we know that a nickel is worth 5 cents. And when we do these problems, we're not going to write it like this. we're just going to write 5. We're going to move all our decimal points over 2 places to the right. So we have 5 times the number of nickels, and we know dimes are 10. It would be 0.1, but we're going to move our decimal point over 2. So we're going to have 10 times the number of dimes. This is all dealing with the value. So that equals the value of $4. And since we moved our decimal point over 2 for these, we're going to move it over 2 for the $4. I want to say 400. That's our value equation. It's having to do with how much money. The second equation is just the number of coins. We have 50 nickels and dimes. So the number of nickels, no value attached, just a plain old coin, plus the number of dimes is going to equal 50. So this is one of those where you can either do substitution or you could do elimination. Let's just do elimination. Let's multiply the top and bottom, or the bottom only, by negative 10. I don't know if I'm going to fit this all in here either. So we have 5 times the number of nickels plus 10 times the number of dimes equals 400. And so that would give us negative 10 number of nickels minus 10 number of dimes. You could have easily done substitution here. Equals negative 500. And we're going to draw a line. And we're going to add till we get negative 5 number of nickels equals negative 100. Divide both sides by negative 5 and we get the number of nickels is 20. And so if we put that up here, that means the dimes have to equal 30. And that's it for that problem. Okay, let's try one more of these. The fishmonger sold codfish for 6 pence each and mussels for 1 pence each. If Harriet bought a total of 26 items and spent 86 pence, how many codfish did she buy? Now the thing is, we don't know, we don't deal with pences in this country, so this one's a little bit different. So let's give this one a try. So we're going to set up a value one that just has the value of each pence, and we're going to set up the total number. Now there's a total number of items. The coins add up to 26. Let's do a value one first. You don't have to do the value one first. Let's switch it around this time. Let's do the number of coin one first. So we had codfish for 6 pence and mussels for 1 pence. So the number of codfish plus the number of mussels equals, well, there's a total of 26 mussels and codfish. Now we're going to assign the value. Each codfish was 6 pence, each mussel was 1. So we would say, what did I just say? Codfish was 6. So 6 number of codfish plus, we don't have to write the 1 there, number of mussels equals 86. It's like $86, 86 pence. And now we're going to do elimination. Let's see, we can just multiply the top one by negative 1, right? And we can eliminate our mussels. So we have negative number of codfish minus the number of mussels equals negative 26. 6 number of codfish plus number of mussels equals 86. And I don't know if I'm going to put this all in here. Let's move my little thing down here. Oops. There we go. So we're going to have 5 number of codfish. The mussels add out equals 0. And we're going to get 40. And yeah, 60. So we divide both sides by 5. We'll say the number of codfish equals 12. And then you just have to figure out the number of mussels. And we would have to put it up here, get the number of mussels, and that would be 14. Now I did these rather quickly because we did do these last year, and we'll go over this in class tomorrow if anyone has trouble in it. So give it a try. Just remember, you're going to have your item total, and then you have your value total, how much it costs. So that's it for lesson 19. Hopefully that was helpful.